Welcome to another edition of Illinois Innovators. I'm Mike Kuhn. Joining us now, Monty Golparvar. He's a professor of civil environmental engineering here at the University of Illinois, and also CEO and co-founder of Reconstruct. And first of all, welcome to the program.
Thank you very much. Glad to be here.
Give us a little background on yourself, your history with construction. I know that's has been a big focus of your career thus far. Just give us a little background to start with.
Sure. So by education and training, I'm a civil engineer. So I have worked in many capacities in the construction industry. I started my work as an intern, being a CAD specialist. That evolved into project controls position. Then I evolved into virtual design and construction engineer. I have helped projects in the capacities of scheduling, cost estimation, and my latest work was with a company that's called Turner Construction. That's the largest construction management company. And this was back in 2008 to 2010 when Turner Construction was involved in construction of the Eikenberry Dining Hall and Residence Hall. So I started a project with Turner and I finished those two buildings with Turner Construction. And since 2010, I've been very actively working with construction companies in the capacity of an assistant professor and now associate professor. I've also consulted construction companies. So I'm very glad that through our program at the University of Illinois, we're currently working with more than 50 construction companies on and off at different capacities. Turner Construction, Gilbane Buildings, we work with Clark Construction, who's been greatly supporting us, DPR, just naming a few, but we've been very fortunate that we have this support.
Well, there's been a lot of interest in the flying superintendent, and so just talk about the evolution of that, what that is, and the collaboration that took across disciplines to make that happen.
Wonderful. So glad you're asking this question. It's sort of nice segue from the previous question because part of my background is also computer science. So since 2005, 2006, I've been really interested in computer vision and machine learning. And computer vision is the study of images and videos. I've been really interested to see how we can take these emerging sources of data on construction sites and transform them into actionable analytics for construction companies. So we're interested in looking to images that are being captured by commodity smartphones, time-lapse cameras that we have on job sites, laser scanning devices, action cameras. People are using GoPro cameras to walk around and document construction sites, and most recently drones, unmanned aerial vehicles that we have on job sites that are equipped with cameras flying around, and they can provide us with the visual data that we need. So the idea really came from the background that I had in computer vision with the intent of transforming into actionable analytics for construction companies. So at this project, Flying Superintendent, we started looking to how we can use such visual data to improve planning, how we come with the schedule for a project, how we can better coordinate the work that needs to be done between contractors, subcontractors, suppliers, and the owner, together with the engineers and architects, and bring better tools for communication so we can ultimately improve transparency on construction sites. So as part of this project, Flying Superintendent, that really kicked off back in 2012 when I came back to University of Illinois, we had the opportunity of looking at this problem from an end-to-end solution perspective. So I met with two of my colleagues that I knew from the past, Professor Derek Hoem in the Department of Computer Science. I also met with Professor Tim Brettel. He's in the Department of Aerospace Engineering. And the three of us started brainstorming on this idea of coming up with an end-to-end solution to support capture of visual data, analyzing that visual data, and ultimately reporting in a way that's meaningful for construction practice. So this Flying Superintendent is really now a web-based platform that continuously reconstructs construction sites in 3D. So we have a mechanism, a computer vision solution that gives reality on job sites to various parties that engage in the project. It integrates them with models that we use for planning. In construction, we call them building information models. These models are tied into the schedule of the project. So we have reality, we have the plan, both in a visual form. Now we have analytics that compare the two and report status of progress and productivity. Another opportunity that we've explored in this Flying Superintendent project is predictive data analytics. So now we can actually predict locations, tasks on the construction sites that are likely going to be delayed in the future. this transforms today's construction monitoring control practices to be more proactive. Instead of reacting to problems that companies have and face on a weekly basis, now we offer analytics that can help them tap off delays before they surface on their job sites. So ultimately, it improves capabilities of planning, coordination, and communication on job sites.
Well, and with your connection to Turner Construction, one of their big projects was the new arena in Sacramento for the Kings. Talk a little bit about that project. How much freedom did they give you, and obviously the use of drones with that project. How did that work out? What are some of the feedbacks that you got from that project?
Yes, thanks for asking. We've been really fortunate with the support that we received from all construction companies, and in particular Turner. The connection and my background of working with Turner was more helpful in establishing the first more of a full-scale pilot project that we conducted at the university. So through Vice President of Turner, who is a great supporter of our program at the University of Illinois, we got connected to various offices at Turner Construction, and they have 12 different regional divisions. The one that immediately responded with a site that they wanted this flying superintendent project to be piloted on was Northern California's office. In the Northern California's office, one of their projects was the $500 million Sacramento Kings Stadium. They were very actively looking to application of billing information models. This is a really large job site with hundreds of workers on a daily basis, tens of contractors that are working simultaneously. So there was a need to figure out how you can track work in progress, how you can bring transparency of who does what work in what location, and ultimately improve the practices that are typically conducted. So we got started with the support of the headquarters at Turner Construction, but also support that we received from Lincoln Wood, who is regional manager for virtual design and construction in Northern California. We established a workflow. We engaged a team on the job site, so we had a number of point of contact. And as a campus and with the FAA regulations, we don't operate drones. So Turner was generous enough that they also financially supported the drone operations. A third-party imaging flight was hired. Great colleagues that we have in Northern California, and they started operating drones on that site. And ever since, we started receiving visual data.
So, how did the project go? I think it has been completed. What are some of the things you learned from that, and what were some of the benefits that you heard from them in terms of how this helped support the project?
Yeah, this is an interesting question. So, we started working at Sacramento Kings when we just had a simple working prototype. When you are getting engaged in pilot projects, the expectation is that you would be offering them an engineered solution that always works and is always reliable. So the gap between a prototype to a working solution was something that we had to focus on. That's something that we don't usually do through university research. So with the team that we had in place and the great talent students that we had on board, we were able to transform parts of this prototype into a solution that Turner can immediately start working. So we started by generating these reality models in 3D, give them access through web-based platforms, various individuals from a safety perspective, from a planning perspective, from a project management perspective. And we engage them in the effort of giving us feedback. So we had regular meetings with them to make sure that ultimately we are adding value by offering a solution that tracks work in progress. Another opportunity emerged out of it, which was Turner got excited and they wanted to make sure we also have a physical presence on the job site. So they hired one of our students as an intern. Very unusual process of having a student doing an internship for a company that is actually driven by an idea from a university. So it was not just that we would have an intern that would do a regular intern work, but rather taking the ideas that we have at the university and transforming into tools that people can use immediately on the job site. So this was a great learning opportunity. We received a lot of feedback and really evolved our project from just a prototype into a working solution. While we were working with the team at Turner, with the attention that the project received through media, we also received emails and phone calls from various construction companies that were also our partners. One example was Clark Construction. We had colleagues at Clark, their innovation and research and development team out of Maryland. They came to University of Illinois. They visited us because they wanted to also identify a pilot project that they could be involved in. And we've also been very fortunate with them. We got involved in a project in Chicago. We've been involved in McCormick Place construction project, a project that is also more than $500,000. And we're very glad that we've also been able to support that project extensively. That experience has also been extremely helpful to us. The site was closer. The team was extremely engaged at various levels. So these experiences, again, are very helpful for us to make sure not only we create prototypes that are scientifically sound, but they're also engineered enough and they actually add value to the bottom line, which in this case for construction project is to make sure the projects stay on schedule, on budget.
Well, one of the interesting things about this project is that it's turned into a startup called Reconstruct. So is this something that you thought about at the very beginning? Hey, we're going to turn this into a startup. How did that happen? Where did the funding come initially, and how did the ecosystem here at the University of Illinois really help drive the formation of Reconstruct?
Perhaps I can start slightly in a different way. Obviously, Flying Superintendent was created as a project with the intent of supporting construction industry. So it was really application driven with a lot of opportunity for contributing to body of knowledge and science. So given the application in mind, obviously from day one we knew there's a huge commercial opportunity through the underlying solutions that are being offered through Flying Superintendent. But we really wanted to take baby steps, and we wanted to make sure that we take advantage of the ecosystem that we have at the university to support us and make this endeavor a success. I have been involved in other startups in the past, and every startup has its own challenges and opportunities. So in this time, the great opportunity what we had was that we had knowledge of the application. We had knowledge of computer vision on our board with Professor Derek Holm from Department of Computer Science. We also had the knowledge of robotics through Professor Tim Brettel at the Department of Aerospace Engineering. And we also had the amazing talent of students engaged at various capacities. Students that wanted to do the basic research, students that were more interested in developing solutions, and students who were interested in taking the solution and applying them to the practice on job sites. So our strength through university was really the team that we were able to put together. Now, while we were pursuing this project, College of Engineering started a new initiative, which was the Faculty Entrepreneurial Fellowship. This was an initiative that was laid out about 2 years ago, and we had some initial conversation with Technology Entrepreneurship Center and also Office of Technology Management. Obviously, it's an effort done and managed through Technology Entrepreneur Center. So we took advantage of this. I applied for the opportunity of the fellowship, and the team was generous enough that they chose me and this project to be one of the inaugural projects that we have for this FEF program. This really helped us create a proper business model, have a commercialization plan for a potential startup company, and we were able to engage many students, not only from the engineering side of campus, but also from various groups. We had students from industrial design, we had students from graphics, we had students from College of Business that got engaged in the project. We really put together a team that contributed to the startup. The fact that we had the industry support from day one, even without having a company, was extremely helpful as well. That really let us have projects even before we had a company. So overall, where we are today is that there's an entity formed called Reconstruct that offers this technology that's been matured enough to the construction industry, and it has benefited significantly on the technical side from support that we had through tech. But this is only half of the equation. Obviously, tech did a great job in not only technical support, financial support, but also helping us understand the elements of business and commercialization that our team really needed mentorship on. But beyond that, we've also received other financial supports. The creation of the prototypes was initially financially supported by National Center for Supercomputing Applications. So NCSA was really instrumental in forming that idea. That idea was helpful in securing a funding. We received $1 million funding from National Science Foundation, and that really led to the prototypes that we started using together with Turner Construction, Clark Construction, and other companies that we're working with. So many elements and many individuals at the university and beyond started helping us to transform this project to what I'd like to consider as a success.
Well, I want you to have an opportunity to go into detail about the visual data analytics for construction management system, which is all part of this, I'm sure. Give us a little background about what is the nature of the construction industry, and what are the challenges that it faces in terms of trying to finish on time, on budget, and how is this system in general helping the field?
Yeah, that's an excellent question. Perhaps I would like to start by, bringing a little bit of clarity to state of construction industry in the U.S. So we are looking at an industry that is slightly over $1.1 trillion a year value of work put in place. So you're speaking about a very large industry, but at the same time, with the opportunities that we have with the growth, that today is somewhere between 7 to 10% across various sectors of the construction industry, construction has been challenged with lack of or stagnated productivity rates. If you look into manufacturing non-construction industries over the past 20 years, more or less value put in place per worker has been increased by magnitudes of twice, doubled. Basically, that's how much productivity has increased. While in construction, the status of productivity has almost remained flat. There's been a lot of research done on what the factors are that are contributing to this status of productivity, and we're really interested in exploring that. The National Academy of Science put an effort about 5 years ago to bring visibility to the problems in construction industry, and more recently, at the commercial level, McKinsey and Company has also established a number of studies that look into this more specifically. So one of the biggest issues that really surfaces when it comes to productivity is the lack of understanding on the owners, contractors, and subcontractors side in terms of how much progress is really being achieved on job sites. The practices that we have for tracking progress are really time consuming. Over the past 5 years, we've transformed paper-based tracking methods to electronic-based methods, but we still rely on our field engineers walk around the job site, making observations that from time to time could be subjective, collecting reports, putting them into a system, and ultimately making an assessment on the status of the progress. We usually don't trust all the numbers that are coming from various parties that engage in the project. This is one of the challenges of construction because you have many parties that are engaged. So speaking about, somewhere between 30 to 50 teams that could be working on even a $50 million project. So you'd be expecting each of them to report you how much work is happening and somebody analyzing that data. The process is inefficient. So what happens is that you usually wait until all parties come to a meeting, which we call a weekly contractor coordination meeting. And that's where you have some transparency in terms of how much work has been done. Now, what that really means is that from the time that the problem happens to the time that that problem gets surfaced to the project management, you could have lost a week of time on the issues that are happening to it, right? So problems keep stacking up. That was one of the problems that we really wanted to address. The second problem is, over the past 10 years, 20 years, we've really matured our capabilities of planning and scheduling construction projects. These are long-term plans that we establish for projects. But when it comes to understanding how much work could be done every day, every week by various teams, there's a lot of room for improving that. The practices that we have are retroactive. As I mentioned, people walk into meetings, they learn about actual problems that have happened without any ability to analyze risk and predicting risk in the future. So, all of these are obviously leading to poor decision making. So not only we were interested in addressing these problems, we wanted to come with a methodology, an approach that is easy to understand by various parties. As you can imagine, you have people with different levels of expertise and understanding involved in a construction project. So we wanted to make sure everyone, from an owner's side, from the contractor's side, from the designer's side, they're all on the same page in terms of what needs to be done every day, how much work has been completed, and what is the risk with respect to the plan in the future. So the fact that we started looking to the visual data was primarily driven by the fact that images and videos are really easy to understand. Everyone can see an image and really understand what's going on. You don't need to provide any text description of how much work is being accomplished. So that was a huge opportunity. The other element of opportunity is what we at the University of Illinois we've really championed, which is ability to image an object or a job site. So now we have tools in the smartphones, now with the drones, with commodity cameras that allow you to capture images and videos at a massive scale. You're speaking about hundreds to thousands of images that could be captured every day. So we really wanted to put all of these together and see how we can transform them into data analytics that visualize and communicate actual problems, and they also predict risk in the future. So all of these pieces really came together to form Flying Superintendent and address the bottom line, which is understanding actual productivity rates on the job site, performing root causes of these problems, devising plans that can tap off delays in the future, and making that plan work with the anticipation that you can keep the project on budget and on schedule.
Well, I know there have been a few stories that I've worked on, and I've worked on this story off and on for a couple of years here, that I've got as much feedback. So the interest in the industry certainly is there. Give us an idea of the impact you're having. I know you talked about in August, you've got a significant amount of additional funding. Over the last 2 or 3 months in the Faculty Entrepreneur Fellowship Program, you were able to really focus on this. So, where does this stand in terms of a leader in the industry? And what is being part of the FEF program enabled you to do? And just give us an idea of just the impact that it's having.
Yeah, the exciting part of it is that this is something that has been created and developed out of University of Illinois. I am a graduate of University of Illinois from Department of Civil and Environmental Engineering. I've also graduated from Department of Computer Science, and since I've been back as a faculty member, I've contributed to a number of efforts on this campus. So the excitement for me is the fact that in the area of construction monitoring, we now can be called leaders. We have contributed to the body of knowledge. We are creating the technology, and we are showing that we have engineering power through students and graduates that we have from College of Engineering. They can actually create systems that work, and they contribute to the bottom line of construction projects. So, having said that, we were fortunate that with the support that we had through tech, we were able to pitch this technology and pilot projects that we've done to a number of venture capital firms. And with the support that we have from the local community, we were able to engage 4 different investors. We're very fortunate that we have some of these investors in our close proximity. They appreciate what we do at the University of Illinois, and they've invested in Illinois-grown technology from University of Illinois. So Sarah Ventures, Illinois Ventures, we have Grand Angels, and we also have Harbor Street Ventures that have all contributed to the company. And now the technology, certain elements of it have been transformed into intellectual property. The intellectual property has been licensed by the company. So now also University of Illinois has an ownership of some form in the company. And what's happening with the company is that we have now funding in place. We've hired a number of full-time employees and a number of part-time. Some of them, actually most of them, are from University of Illinois. That's another element of excitement, that we've been able to bring our own students into the company. And what we're trying to achieve is to really make sure we establish proper projects through the company that can actually show that this technology is working, create a plan for additional tech development, and streamline the process of generating ideas from campus into prototypes that get licensed through Office of Technology Management, and ultimately developed at a startup company in our community that can make an impact beyond state of Illinois and United States.
Give us an idea what the future looks like in this industry. It seems like it's changing rapidly, and you're right at the center of that. As construction managers, approach major projects, multi-million-dollar projects in the future, how will it look differently, especially considering the technology you're developing?
That's an excellent question. Now that, we have a startup company in place, and we are still continuing our research through university, we've been sort of thinking about this from a two perspective problem. So from one side, we are really looking to product leadership, which is something that we like to really pursue through the startup company. But we're also looking to thought leadership, which is something that we like to pursue through the involvement of University of Illinois and faculty and students at the university. So the product leadership perspective, we're interested in being able to support every project that is happening, that is currently under construction or would be under construction in the near future. We don't want to be limited to only mega projects or large projects. Many elements of our technology can work even for projects that are as small as $1 million, $2 million. And there are ways by which we can achieve that through our product. But at the same time, on the thought leadership, there are many elements of the work that still can be automated. One particular opportunity is through robotics. So, for example, today's practices, we are operating drones with the FAA regulation in place. You still need to have operators that keep line of sight to the drone operation, and our third-party teams that are working with the drone operation are very professional in delivering the data for us. But there's a lot of opportunity in showing agencies like FAA that through science and methods, there are ways that you can definitely secure safety when it comes to operation of the drones. Now, drones are great for exterior capture, so we plan on continuing that through the support that we have with our colleagues at Aerospace Engineering Department, but we're also very interested in moving indoors. Now, our colleagues at Aerospace Engineering are experts on this topic, and they can attest to the fact that engineering a solution for a drone that can operate inside with the capability of capturing images and videos in an autonomous way, there's still more research that needs to be done before we can engineer a solution out of it. So one of the other things that we've been looking at is using a ground robot that can automate the process of data capture inside the building. Now, this idea may sound futuristic when you're speaking about this to a construction audience, but in fact, both Turner Construction and another company that we have, DPR, have both shown interest in ground robots with the ability of doing interior capture. Now, first, we need to create the science behind it, which is the visual data analytics. We need to create a prototype. Then we have to transform that prototype into a solution that works, pilot that at scale on the job site, and eventually bring it into the practice. So, keeping these steps in mind, we've taken the very first steps of it through University of Illinois. So Professor Tim Brettel, my colleague that has been great support of the flying superintendent, he's really been leading this effort. He taught a course in Department of Aerospace Engineering last semester. That the idea and the application that he considered as part of the project for that class was really developed through this collaboration that we had in Flying Superintendent project. And he was able to very effectively engage students across various departments on campus, from civil engineering. We had students from computer science, from electrical and computer engineering department, also aerospace engineering and mechanical engineering. Now you're putting groups with different levels of expertise and talent, and you're leveraging the synergy that could be created across teams with the intent of creating a ground robot that can actually automate certain tasks on job sites. The experiments that we've done with the platform have been extremely successful. We are very excited with the leadership that Tim Brettel is bringing to this project and leading the project forward. Professor Derek Holm from Computer Science continuously supports this project. Many other faculty are also contributing that I'm not naming here, but both across CS and ECE and even AE department that are contributing to this. So this is a direction that we're taking, which is transforming our tools to be fully autonomous. Now, the moment that you introduce the element of robot, there's so many other tasks that could be automated through construction, things that at the concept level, they were developed in some 10, 20 years ago, but funding wasn't allocated to it because our capabilities of sensing our environment hadn't advanced. But with the leadership that ECE CS department has brought into this domain, now robots can actually be used as commodity on construction sites. So now we are more looking to the elements of analytics, elements of planning, and elements of control with the intent of automating repetitive tasks and let engineers focus on more important task of decision making as opposed to capturing and collecting data.
Well, I'd be remiss if I didn't talk about just and you have mentioned it throughout this interview, that the collaboration between departments. I know you've got had mentioned that there are classes that are taught in civil engineering that computer science students are involved with, but specifically civil engineering, aerospace, computer science. You've got several other potential projects that the benefit of being a computer science major, being able to take a civil engineering course and really get involved in these projects is very exciting.
Absolutely. This really formed out of an opportunity that Technology Entrepreneurship Center offered us, which was this FEF fellowship program. So through that, I started teaching a new course that Technology Entrepreneurship calls it Breakthrough Innovation Teams, and I specifically introduced this Flying Superintendent as a class that the students were able to start taking. And a lot of the students that got engaged in the project were initially channeled through the Flying Superintendent, and the synergy and excitement really led to many things that we did. So we continued with the Flying Superintendent as a course for 2 semesters. We also had the elements of the course that was offered at the aerospace engineering. We transformed elements of a course that we taught in civil and environmental engineering department on building information model, and we actually brought 12 guest speakers that not only they interacted with the students in class, but they also got engaged with the technology that was coming out of the Flying Superintendent, and has actually led a lot of our students across these departments that were engaged to think about other startup companies that could be built, or even channeling their efforts into what we've already formed out of the university. So the ecosystem that we have at the College of Engineering, broader at the University of Illinois, the amazing support of Tech, and the vision that was set both by the dean and the leadership that we have at Tech, Professor Andy Singer and Jed Tyler, has been really instrumental in transforming ideas that we all work on campus into things that excite the students from an engineering perspective, from a business perspective, and ultimately by showing that we can have a societal impact. In this case, as National Academy of Engineering had identified, improving productivity in the U.S. is a national imperative. At a larger scale, our goal and hope is to be able to contribute to that and be able to make our projects more effective. So the ecosystem has been playing a huge role. Office of Technology Management has also been very instrumental in transforming ideas to products to intellectual properties. And we hope that we can leverage this experience and expand on it. I really like to consider this to be a leading effort at the College of Engineering, hopefully for another 5-10 years, where we would establish leadership in automation and robotics in construction with a specific focus on visual data analytics.
Fascinating stuff. We could probably talk for another couple of hours and still maybe not scratch the surface on this, but I appreciate your time, and we look forward to hearing how things advance in the future.
Well, thank you very much for the opportunity. Happy holidays to everyone. Thank you for listening in.
Mani Golparvar from the Department of Civil Environmental Engineer and the CEO and co-founder of Reconstruct. This has been another edition of Illinois Innovators. I'm Mike Kuhn. Thanks for listening.